A very good day to everyone. Myself, Neha Priya, working as assistant professor in IIMT College of Pharmacy. Today, I'm with my video lecture consists of a topic that is high performance liquid chromatography, or you can call it as high pressure liquid chromatography. In short, we call it HPLC. So let's move forward this video lecture and let's get the contents involved in this lecture. So the contents below here is first is what is HPLC, second is the principle involved in high performance liquid chromatography along with its instrumentation, types and application. So let's get to the first topic, that is what does HPLC mean. So basically HPLC is an analytical technique used to separate, identify or quantify each components in a mixture. First we need to understand what is mixture. Mixture basically is a substance basically mixture consists of two or more substance within it. For an example, if I am having a mixture C, then A and B are there present as a constituent in that mixture, and these two when combined together forms a mixture that is C. So first thing what HPLC does is it will separate out A and B out of C. Okay, so basically from C, it will separate out A and B. Second thing, what it will do is it will identify what A is and what B is. Third, what it will do is it will get us the result of how much A is present in that mixture and how much B is present in this mixture. So basically, these are all the things that HPLC will do for us. Basically, what happened here is first, if we like for first when anyone wanted to separate C into two parts, that is A and B, we first went for column chromatography. In column chromatography, what happened is there's the presence of one stationary phase along with one mobile phase and sample. Stationary phase is made into within the column, and the mobile phase has been poured into the column regularly. First, what we'll do is we'll put our sample into the column and we'll pour our mobile phase into the column. Then what will happen is, for an example, if A is having more affinity towards stationary phase, it will get attached to the stationary phase and it will not move or elute out with mobile phase. Whereas if B is having more affinity towards mobile phase, it will move out with mobile phase. It will not get attached to that stationary phase. And in this way, the two components of C will be separated, one with the mobile phase and one will remain within the stationary phase. This is what column used to do. But there was certain limitation with column as it was not precise and accurate. So we went towards HPLC. First in 1960s, what we found out was we have given low pressure suitable glass columns and wanted to separate out, but the result was not improved and were not precise. Then we went for high pressure, and when we gave this high pressure, then the results were more accurate and more precise. Thus, we went for HPLC. HPLC basically, like in earlier column chromatography, used to work on gravitational force. For an example, the column was put like this, and the mobile phase used to run from the column. With the help of gravity, the mobile phase will come towards the it will come flow within the gravitational force energy. But in column, we use high pressure for this flow. So this is what basically HPLC is and why we are using HPLC. Let's get to the principle involved in HPLC. So we'll take example of the same component, that is C, and we'll give A as glucose and B as sucrose. Let's get to this. For an example, I have to separate C by using HPLC. First, what I'll do is I'll prepare one sample. After preparation of sample, what I'll do is I'll put that into the sample into the HPLC, and by the help of the injector will inject this sample and give this sample to column. From solvent reservoir, the solvent or the mobile phase will run towards the column. Sample is given by the injector, and stationary phase is always present within the column. So when this column will get all the three components required for separation, it will do the separation. Then further, as the separation will take process, As the separation will take process, the two components will start getting separated according to their affinity towards whatever sample they are having, whatever stationary phase or mobile phase they are having. According to the affinity, they will get separated, and after the separation, the detector will detect these two samples, and after detecting these two samples, it will give us one result. By the help of spectroscopy technique, that is UV IR, it will give us a graph will be between absorbance and retention time. Now take it as an example. I have already mentioned A as glucose and B as sucrose. For an example, A glucose graph retention time is 6 and sucrose is 7. If I am having a graph representing 7 retention time, then I know that it is of sucrose, and by this I can identify my compound. After identification, I look towards the graph and calculate the area under curve. And by calculating area under curve, I'll get the quantity of how much components of sucrose is present in the sample. And in this way, my sample will be separated out, identified, quantified by HPLC. So this is what HPLC is. Nowadays, earlier we used to manually inject the sample within the HPLC, but now we can go for we are using automatic sampling, as well as the softwares for the HPLC has also been advanced for our use. Next one is the instrumentation involved in HPLC. So basically, first thing is solvent reservoir, where the sample or the mobile phase we have to put. Then this solvent went to the pump. Pump will give us the high pressure which is required for the sampling. After this high pressure, in between the injector will inject our sample. With high pressure, this mobile phase and sample will come into the column, and where the separation for the same will be done. After the separation will be done, the detector will detect the result. Waste thing will be eluted out, and the result will be shown in our data out unit. So let's get back to the each components and get an idea what each components consist of. So the first thing here will is so the first thing here consists of the pump. The pump basically gives us the high pressure. That is the most important thing in HPLC, and this is the only part which will give us the precise and the accurate result, as I have already mentioned earlier. Basically, the pump is positioned in the most upper stream of liquid chromatography system and generate a flow of elute from solvent reservoir into the system. It will just make a possible high pressure to make our mobile phase go with the sample into the column with a high pressure. Thus, the separation will be done precisely. Most pumps used in LC system generate the flow of back and forth motion of a motor driven position. This is reciprocating position. Because of this piston motion, it produces pulses that can, affect our result. High pressure generation is a standard requirement of pumps, beside which it should also be able to provide a consistent pressure at any condition and a controllable and reproducible flow rate. Because if the flow rate will change according to this pressure, then only the result will get or precise. If we are not having an exact flow rate which is required for the separation of a particular component, then the result of ours will fluctuate from by each process. For an example, if I am doing one analysis today and one analysis day after tomorrow, I have to optimize the flow rate, because if the flow rate will vary, then the result of the same will also vary. So the pump is the most important part out here, because it will give us the high pressure which is required in high performance liquid chromatography. The second thing involved in the instrumentation part is injector. What injector will do is it will inject our sample into the column. Earlier we used to manually inject the sample, but that was not precise. Thus we moved towards the auto sampling part, where the work is where the work got more easier and more accurate because of this. So injector is also main important part. First thing is solvent reservoir, second thing is pump, third thing is injector. After the injector, the sample has been given to the column, and in column all three parts are present now. For an example, I'm having my solvent, I'm having my sample, and the column is having stationary phase. Now the separation will be carried out. Earlier, column was made up of glasses, but now it is made up of stainless steel housing. The packing material generally used in this is silica or polymer gel compared to our sample. The elute used for LC varies from acidic to basic solvent. Most column housing is made up of stainless steel. Since stainless steel is tolerant towards a large variety of solvent, thus we have moved from glass to stainless steel columns. The last thing used in the HPLC is detectors. In HPLC, as I have already mentioned, we go for spectroscopy technique. For an example, IR spectroscopy and UV rays, which are used here as detector. Mass spectroscopy is also used in HPLC as a detector. What happened here is the detector will detect the result and give us the result in two ways. The result will be in the form of, the graph will be between absorbance and retention time. The only limitation HPLC give us is that we need to understand the retention time of each components. Like I have to understand the retention time or the standard time of each components, then only I'll get to know the result. So this is the limitation what HPLC gives us, yet it is one of the most accurate techniques, and still most of the industries, whenever they buy some raw material, they want COA with the HPLC result. For an example, if I am, I have to develop certain tablets or certain formulation, then I'll buy the raw materials, and that raw materials need to come with a COA where HPLC results need to be mentioned, because that will give me the surety that the raw material is good or not. If HPLC result is fine, then only the raw materials or any manufacturer buy the raw material from the other manufacturers. So detector is the most important part. It will give us the a result for the same. The difference in is measured in the form of electrical signals. There are many different type of detectors. As I have already mentioned, we can go for UV, IR, or mass spectroscopy, which can be used as a detectors in both HPLC and GCGC is called a gas chromatography, where we used to separate volatile substance from where we used to separate volatile substance. Next thing is detectors. Earlier we used to just write it on a paper about the result of the same, but now we are having basically computers used as a readout unit, where the detector will detect by the detector is an electrical signal, and it is not visible in our eyes, but within the readout unit we can get to know the result of each sample. There are various type of data processor from a single system consisting of inbuilt printer and word processor, while those with software that are specifically designed for HPLC, which not only data acquisies but features like peak fitting, baseline correction, automatic concentration calculation, molecular weighting determination. All of these are mentioned in the software, and still softwares are getting updated for us to get more result out of HPLC or any other instrument. So detectors and recorders are the most important part in HPLC too. Once again, let's get back towards the what we have learned from the instrumentation of HPLC. The first thing which we need to have is solvent reservoir. Then pump will move that mobile phase into the column along with sample that will come to from the injector itself. When this injector will inject the sample, it will move towards HPLC column. Now in my column, I'm having all the three components, that is my stationary phase, mobile phase, and sample, that it will separate my mixture. When the mixture is separated, it will come towards the detector. Detector, as I have already mentioned, UV, IR, and mass are used here. Detector will detect the result and give me a result on readout unit in the form of graph which will be between absorbance and retention time. So this is what HPLC's instrumentation consists of. The next topic which we are going to learn here is the types of HPLC which we are using. So the first type we are having here is ion exchange HPLC. Basically what happened here is we separate our components according to our ions present in the mixture. For an example, if I am having a positive like cationic presence, or I want to separate cation from anion, then I'll be using Then this will be done by ion exchange HPLC. As positive will, the stationary phase, stationary phase consists of positive ions, then the negative will get attached to the stationary phase, and all the other phases will move out with the mobile phase. Thus my one of the component is separated from by the help of HPLC. Column packing contains ionic group, and the mobile phase is buffer. As mobile phase is buffer, it will elucidate all the impurities and other things which I don't want to separate, and the column will be made up of my choice of ion. Thus, I'll separate my choice of ion from the mixture. Then the next one is size exclusion HPLC. Basically, size exclusion itself explains that we have to separate our sample according to the sizes. For this, we are using porous material. As you know, in a porous material, there is a presence of some air, like there's presence of space. And my column is made up of that porous material. Then there is the presence of some space within that. When I put my sample into the column, what it happen is the sample will, some of the mixture, like small particle mixture, will, cover that, or will try to get trapped within that space and fill out that space. And the large particle material, or the large particle components, will come to from with the mobile phase, and in this way the large particles and small particles will get separated within the HPLC. That is size exclusion HPLC. The other two types of HPLC here are normal phase HPLC and reverse phase HPLC. So the first thing which we need to learn is, in normal phase HPLC, stationary phase is made up of polar substance, and mobile phase which we are using will be non-polar. In reverse phase HPLC, stationary phase will be non-polar and mobile phase will be polar. So basically they are opposite to it. That's why it is named as normal and reverse phase. Column packing is polar in normal phase. It is mostly made up of silica, and mobile phase is non-polar. It is used for water sensitive compounds, geometric isomers, cistrons, and chiral compounds. The second one is reverse phase. The column packing is non-polar, that is C18. We have used it as in column. The mobile phase is mostly water or miscible solvents, example methanol. It can be used for polar, non-polar, ionizable, and ionic sample. So they basically, what we have learned here is HPLC chromatography will be can be of four types. First one will be ionic, second one will be size exclusion, third one will be normal, and fourth one will be reverse phase HPLC. Now to the last topic which we are learning today is application of high performance liquid chromatography, or HPLC. As I have already mentioned earlier also, it helps in identification, purification, separation, and quantification of compound. But let's quote all the applications out here. The HPLC has developed into a universally applicable method, so that it finds its use in almost all the areas of chemistry, biochemistry, and pharmacy. In this, what we can do is we can analyze drug analysis of synthetic polymer, analysis of pollutants, and environmental analytics, determination of drugs and biological matrices, isolation of various valuable products, product purity and quality control of industrial products, separation and purification of biopolymers, water purification, pre-concentration of trace components, liquid exchange chromatography, ion exchange chromatography of proteins, high pH and ion exchange chromatography can be used in the separation of carbohydrates and oligosaccharides. So basically, these are the mentioned application of HPLC. Now, let's learn what are the factors on which we need to work on to get HPLC more accurate, more precise, and more helpful to us. So basically, the factors which influence HPLC performance is in internal diameter of column. Basically, the smaller in diameter, the higher in sensitivity. So if we reduce the column size, then we can get the higher sensitivity in the result. But as per the higher sensitivity, it need to have, it need to be taken care more. For second thing is pump pressure. The higher in pressure, the higher in separation. So we need to take care that there is a high pressure within the pump, and there need to be no variation within the pressure, because that will affect our result. Third was sample size, and sample need to be, in HPLC, we have to use HPLC grade materials only. So this is also one of the factor where HPLC result can get influenced. Fourth is the polarity sample, solvent, and column. The last one is the temperature, as the column temperature increases very rapidly. So the HPLC need to be maintained in a good atmosphere, and we need to maintain the temperature of HPLC. So this is all the stuff we have to taken care of while working with HPLC. This is the HPLC chromatogram. It is between absorbance and time. As I have already mentioned, the result will come within the time, and we need to understand, or we need to learn about the standard time of certain compounds. Then only we can detect that compounds over HPLC. So this is all I have to introduce you towards HPLC. This is just a short lecture on HPLC which I have shared with you. I hope I was some help in this topic. I was of some help with this topic. Thank you so much for patiently listening to me. Thank you.